Hi, my name is Chris Schaffner. Welcome to the Building Technoforum. I am the CEO and founder of The Green Engineer. We're a sustainable design consulting firm based in Concord, Massachusetts. Here we are in pandemic mode, and come to us with all of your sustainable design consulting needs. We talk about three trends changing the way we build. Those trends are electrification, the passive house movement, and the drive to net zero. The City of Boston recently commissioned this study, and one of the things that the study notes is that a large chunk, about 2/3 of Boston's greenhouse gas emissions, come from buildings. And for us to get to carbon neutral, we must rethink the way we design and operate our buildings. And the move is towards all electric buildings. And the reason for that is that the carbon intensity of the grid is decreasing as we replace coal burning power plants with natural gas and renewables. If you look at where we are today, the red dot, you'll see that we have just recently passed where a mixed fuel building would be. And here in Massachusetts, that's going to continue to improve over time. And the study that Boston did really highlights that. What are the strategies for reducing the greenhouse gases coming from buildings? HVAC electrification. So that's basically heat pumps instead of fossil fuel heat. A lot of our clients and a lot of good citizens around the Commonwealth are recognizing this. And so Boston University, for example, is building the new Center for Computing and Data Sciences. All electric, 320,000 square foot building, reducing its carbon emissions and improving over time by being an all electric building. Second trend that's driving things is the move towards passive house. So, of course, you may be familiar with the Cornell Tech building on Roosevelt Island, the tallest passive house building in the world. Some basics of what passive house is. For a residential building, the maximum energy per occupant is limited. Another key part of this is a very low leakage rate from a robust building envelope. Typically, you're looking at R40 walls, R60 roof, and triple glazing. We did a study for a local developer comparing where passive house is against a building that was just completed, LEED version 3 goal. And what you can see is there's a huge difference in the energy consumption, and predominantly that's in the space heating and space cooling. What are the changes that the developer would need to make to meet passive house? Additional insulation in the walls and in the roof, reducing the window-wall ratio, and then using triple glazing. Envelope tightness, 0.06 air changes per hour versus they didn't test before. They don't actually know. And the HVAC systems are where this all pays off because those systems got smaller, about a 2/3 reduction. Third trend, of course, getting to zero, and it's been a trend for a while. I was part of the Governor Patrick's Zero Net Energy Buildings Task Force that wrote this report 11 years ago now. So how have we typically done this? Well, the classic example of the net zero building is net zero with on-site energy. And so the Bullitt Center in Living Building, very cool building, 6 stories, the tallest net zero building that I'm aware of, at least in North America. And what you see here is it's got this very large hat because even as low energy as it is, it still needs that much electricity generated in order to balance out to be net zero. Studies are showing that this works great at very low density. If we can build a whole world of one-story buildings, we can make them all net zero on site. A good example again of this is the Walden Pond Visitor Center that our office did along with DCAM and Mary Ann Thompson's office. Beautiful building, really nice thing. And it's net zero, of course. And how does it get to net zero? It gets to net zero by being a very small building with a very large solar canopy in the parking lot. Now, this is a perfect application for a state park, but it's not something that becomes replicable in the urban environment. And so we need to think of net zero beyond just the building itself and think about the net zero at the community level. And lo and behold, that's how many of the buildings that are achieving net zero are actually doing it. BU is going to bring this building to net zero, but it's not doing it with a bunch of solar on site. Instead, BU is matching the building's electricity load with renewable energy generated from a wind farm in South Dakota. So these all come together in one other new trend that we've been talking about. That's the proposed Massachusetts EZ stretch code. The idea of defining a zero building, a low energy building that is combustion free, so it's all electric. It builds on passive house principles to limit loads, and then it is going to be net zero with renewables either on-site or off-site. I appreciate your time and attention today.